All right, geometry. Let's talk about our first proof. Last week, I introduced to you several angle names. Okay, so we have vertical angles, and we also have the vertical angle theorem. And I always write theorem like this because my college professor did, and I thought it was cool. And the theorem, the vertical angle theorem, is if two angles are vertical, then they are congruent. I really like to abbreviate because there's just so many words. So I write VAT for vertical angle theorem. There's also the linear pair theorem. Sometimes they call it the postulate. Sometimes they call it the property. I don't know why they can't make up their mind, the textbook writers, but let's call it the linear pair theorem. If two angles form a linear pair, then they are supplementary, and you should know we write sups in my class. All right, so linear pair theorem, LPT, LPP, yeah, you know me. All right, now there are more. We learned about corresponding angles. I'm going to abbreviate for this one, so just listen. Corresponding angle postulate. I'll write that full word, postulate. The theorems have to be proved. We have to start from a premise called a given, whatever picture we have, whatever known information, and then we use a series of statements. It's an argument, all right? We're making an argument as to why something is true. So if you have ever argued with someone, you are trying to write a proof, maybe in the conversation, but that is what we are doing. And we're starting from the very obvious and simple, or was supposed to be, and working towards a conclusion, which we want to say is true. Yes, I did do my homework because I was here and I was logged in, and you can check the history, and I got a grade for it. And I press submit on Google Classroom. All those are statements trying to justify something that you want to be true. And in geometry, we write very precise arguments. So it's learning to argue. And as we learn in the Ask an Expert, it's learning to write something like code. So corresponding angle postulate. So we learned that corresponding angles are in two lines cut by a transversal. So if those two lines, let's say L and M, if they are parallel, then corresponding angles are congruent. And I always like to draw a picture. Well, hold on, I'm getting a phone call. I will be right back. Okay, so whenever we have a theorem, I mean, not whenever, because you see, I didn't do it up here, but we usually need a picture. Okay, so if L and M, so I could have written if two lines are parallel, but basically if two lines are parallel, so let's call those lines L and M. This is T. You can call them any letters you want, but these are the letters that we see people use. And we know from our lesson that we have 8 angles. Okay, so if L and M are parallel, then any two of the corresponding angle pairs are congruent. That's called the corresponding angle postulate. All right, and postulates are things we don't have to prove. Theorems, we have to prove. That is why we have two different words. We also have the AIA theorem. All right, and that is if L is parallel to M, then AIAs are congruent. The alternate interior angle theorem. And of course, we have the AEA. AEA, the alternate exterior angle theorem. If L is parallel to M, then AEAs are congruent. And we have the SSI theorem. If L is parallel to M, then same side interior angles they're not congruent. They're supplementary. If you look, if you should be looking to see a pair of angles and see for yourself if it looks to be true. 3 is an obtuse angle. 6 is an acute angle. They are not congruent, all right? Acute angles and obtuse angles are different, but they are supplementary if L is parallel to M. And the last one, the SSE. Same thing with SSEs, same side exterior angles. If L is parallel to M, then SSEs are supplementary. Okay, so lots of theorems, and there's more. There's like a whole lot. Definition of congruence. Everyone kept picking that last year. It drove me nuts. It's not always the definition of congruence for your reason, but I'm trying to give you guys the most popular one. So it's like this. If I've written a theorem here, it's not unimportant. All right, so we're going to work on proofs this week. So angle STW is congruent to angle TWX. And so they've marked that. And that's the first reason is always given. So now let's see RTU. Where's RTU? RTU. That's right here. Is congruent to STW. STW. Ah. Well, you should see that those are vertical angles. And they are congruent because why? Because the vertical angle theorem says so. So we're going to write VAT. And then how about TWX? TWX. So let me choose a different color for these. TWX is right here. Oh, sorry there. And RTU is right here. So we know that those are corresponding angles, but we don't know that the lines are parallel. So we have to say, we can't say corresponding angle postulate because the corresponding angle postulate is only true if the lines are parallel. And we don't know that. We know that angles are congruent. So there's one more property I have to give to you. And this is why Samuel said proofs are so hard, because it's like, oh yeah, here's another property. Oh yeah, here's another property. But after you do them over and over again, you find that you are using the same properties over and over, and it's not so bad. So the transitive property says if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. See, it's like that. 1 is congruent to 2, 2 is congruent to 3. So 1 is congruent to 3. I want you to notice that all of my theorems, properties, postulates start with the if statement and continue to a then statement. Each one of them is always an if-then statement. And so this is the transitive property. Transitive property. You see the TX is in the first statement, and we see the RTU in the second statement, and we see the STW in both of them. So the STW connects the other two. Okay, so but we do see the blue angles in the picture are corresponding angles. So the corresponding angle postulate also has a corresponding angle, which is CAP. So it is the corresponding angle postulate, but since we're using it backwards, anytime you use a theorem backwards, it's called the converse. So all of these, we can write a converse. Are all of the converses true? No. So let me just show you the ones that have a converse that's true, I will put a blue dot. Okay, I'm done. The vertical angle theorem does not have a, if the angles are congruent, they're not vertical necessarily. If the angles are supplementary, they're not necessarily linear pairs, but all the ones down here, we can flip the if and then, and it's still true. So this is just to get you started, and hopefully you come to class with lots of questions like, let's do this one, let's do this one, still don't get it, let's do this one. Okay, and for that reason, the rest of the assignments, well, are pretty easy. Although I did just lose, I lost it. So let me, oh, you know why? Because somehow I zoom. No, this ain't right. It's not right. All right, let me pause it and fix the zoom. I don't even know how that happened. Wow, that was frustrating. This board has become gigantic and it's very difficult to find. Okay, so the rest of the assignments are really easy as long as you find them on the board. So the first thing is triangle. So now after we do parallel lines, we go to triangles, three-sided polygons. And so triangles can be acute, right, or obtuse, just like angles. They can also be scalene, isosceles, or equilateral, right? Isosceles is two congruent sides. Equilateral is three congruent sides. No congruent sides in scalene. Acute, right, obtuse, that's pretty simple, right? If it's acute, it has only acute angles. A right triangle has a right angle and an obtuse triangle has an obtuse angle. So this is a right triangle because it has a right angle. And that's all we know. If we knew the sides, then we could say what it was. But I actually do know because none of the angles are the same. It's also scalene. But I don't know if it wants you to say that. So we'll say it's a right triangle. All right. So a new theorem for you. The triangle. Well, let me write it like this. Triangle sum theorem. And that is if a figure is a triangle, then its three angles add to 180 degrees. The three angles in a triangle add to 180. So we can take these three angles and we can write an equation. This is going to be a real simple equation. 2a plus 2a plus 2a, three angles, equal 180. And so that would be 6a equals 180. And we just solve that. Divide both sides by 6. We know that's 30. A equals 30. All right, so not too bad, as you can see. And there's another theorem. See, so here come the theorems. The exterior, the remote exterior angle theorem. Remote exterior angle theorem. And that would be, so for this, I like to draw a picture. So we got angle 1, 2, 3, and 4. And I'm just gonna, if, you know, these are angles in a triangle, and 1 is the exterior angle. So we're gonna say that the measure of angle 1 is equal to the measure of angle 4 plus the measure of angle 3. So this angle is equal to these two put together. We can talk more about that, but let's use that to set up an equation. This angle is equal to these two put together. V minus 49 plus V. Okay, so on this side we have 2V. On this side we have 1V. We can now subtract V from both sides. And then add 49 to both sides. Good little algebra practice. 95. 95. All right. And the last one, or last two, are from the congruent figures section. So I want to, this again, not too hard, but a congruent statement is not writing these triangles are congruent. It's writing, well, it's writing that, but writing that in a geometric way. So you want to put the corresponding parts in matching positions. So when you look at these two triangles, which angle does N match up to? Well, N is 59 degrees, and so is V. So we want to put V as the first letter in our other triangle name. M is 78 degrees, and so is W. So we want to put W next. Then 43s for X and O. So we got O, so this is X. Corresponding angles in corresponding positions. And then you should also know that the sides, if you look at the sides, NM is 21, and is VW 21? It is. So the sides match up too. How about MO? MO is 27. Is WX 27? It is. And even NO, the first and third letter, is 31, and XV or VX is 30. Okay, so right in those congruent statements, we know everything that's congruent. And so let's look at this, is kind of backwards here. These figures are congruent. Thank you. What is the measure of angle E? Ah, okay, so let's look and find, here's angle E, and this is 53, 37. Okay, so 53 is D. So we know that D and T match up. So it's like that. Triangle D. So we know they're congruent. Now we just got to match them up. So 50, 30. Okay, so now I'm looking and I see 30 in both. And so 30 goes between D and E, and T and V. So we got D and E. If I go like that, DE, I guess I gotta do TV. That way the corresponding DE, TV. Yeah, all right, and then, so it's gonna be DE, and the last letter is C, and TVU. So I worked through the given info to write my congruent statement, and now I can clearly see that E and V are congruent. So E congruent to V, and V is 90, so E is 90. All right, guys, have fun hosting the organizer, and I'll see you on Tuesday.